in the first Pascal. To go over what I'm going to talk about today, I'm going to discuss the various compiler toggles, linker switches, and procedures and function extensions to the Atari Pascal. Also, today I'm going to have some demos of some various graphics and sound programs that MT Microsystems generated for us, and an example of a player missile program created by Bob Fruth of Atari. And then we'll also go in and talk about modular compilation and program chaining. I think I'd like to start off first with talking about the compiler toggles. Last week I sort of glossed over a few of them. This week we're going to try and discuss them in a little bit more detail. The first one I'd like to talk to you about is the entry point record generation toggle. It's known as the E toggle. And what this toggle does is control the accessing of global variables, procedures, and functions between modules during the execution of the program. This toggle is in a default state of plus, meaning that it will allow the user during compilation and linking to pass procedure names and parameters across various separately compiled modules. Now, the significance of this is that the user can, if they want, make certain variables or procedures or functions logically private to other modules in a program. Now, when I talk about modules, I'm referring again to modular compilation, which is a technique of taking a very large program and separately compiling it into smaller modules which can be linked together to create your larger runtime package. Anyways, with the entry point toggle, what one can do is selectively enable or disable the passing of these procedure, function names, or global variables, such that one may use a procedure name twice, once globally, and perhaps within another module private to that module. An example is if I have a procedure name called write hex, a procedure that would write a hexadecimal number. Globally, I might define that to write a 16-bit hexadecimal number. Yet privately within another module, I may define it to do something entirely different. Are there any questions on this right now? Okay. Another toggle that we have is the include file toggle, and basically that is structured as thus on the board. You specify the begin comment $i, which signifies the compiler that you want to include a disk file of source to be included in the compilation, and then you follow it with the device number dn, where n can be any drive number from 1 to 4, followed by the name of the file. That allows us to include a variety of pre-written modules into our program. An example that comes to mind is if we have several programs that we've written, each using a standard portion of source code that might be related to disk I/O. A more specific example is that in the creation of some programs, you may access some include files that are on the compiler disk that relate to predefined variables and functions. One example of this is the file on the compiler disk called isoprocs, which includes some predefined references to ISO standard procedures and functions.
Dave, the include files is in a comment?
Yes.
Why is that?
That's just the way that MT implemented it. It's all of these, basically, in fact, I should mention that all of these are structured as comments within your source. The general form of any toggle, let me use a different color here, is bracket star, $, the letter of the toggle, and then either a plus or a minus, close comment. The plus to signify whether you want that particular toggle on, the minus to turn it off.
Do you have more than one control entity per comment? Comment field separated with commas or something like that?
Not to my knowledge. However, you can place them one right after another. So functionally, you can achieve the same thing. I could say comment $E plus, comment $ID colon whatever file name, comment $X minus to turn off exception checking, so on and so forth, all in a string. But you can't, to my knowledge, you can't string them together, such as $E plus, $R minus.
In other versions that I've seen, you don't need to repeat the $, but it would be like E plus, L plus, and you separate them with commas.
Okay. To my knowledge, that's not how it's been implemented. Okay, I can check it out for you later if you like.
I just thought I'd mention it.
Okay. Okay, anyways, there are 3 other toggles that relate to checking of various sorts during the compilation. One combination called the T and W toggles, T referring to strict type checking, that is to make sure that your variable and type constructs are compatible with the compiler and are not illegal in nature. And then the W, which is a portability warning toggle, which tells you if you are compiling a non-ISO standard program. That is a program that can't be ported from one type of Pascal to another. Generally, the defaults on both of these are minus, that is, they're relaxed. Should you enable them and, say, create a program that is not portable, you'll get a warning, but your compilation will continue. Get an error 500, I believe. And that's just for information purposes. Another toggle we have here for checking is range checking of array subscripts and storing into subrange variables. And the default here is minus, that is, it relaxes this checking, does minimal checking. And then the last toggle relating to checking during compilation is the exception checking, which checks for zero divide, string overflow or truncation, and heap overflow. And the default here again is minus, that is, it's relaxed. Okay, lastly, 2 toggles we have are relating to listing control. One that controls the listing of source to your to the editor or to the printer, and here the default is plus, unless you is plus. Certain include files that come on the compiler disk prefix the source with a L minus, which is to turn off that checking, and then re-enable the, not the checking, the listing, and then re-enable the listing later on. You can go in and edit these files if you like and enable their listing to the screen or printer as you will. The P toggle allows the user to input form feed characters just so that you can generate a nice clean listing if you like. And you can use these or scatter these throughout your program as you wish without affecting the code generation. Are there any questions on the toggles at this point? Okay. Okay, at this point I'd like to talk about the linker. The linker comes in two programs on the Pascal system disk. One file known as link, which then in turn later calls the other link.ovl. What link does is when you type in an L in the system monitor, you would call forth the link program, and link will then ask you for the names of the files that you'd wish to link. And usually what you'll see is a little asterisk prompt, which you'd then respond with your files, say D2 test, comma, passlib /s as an example. Now you might take note here that the linker assumes that there's an extension of .erl to the files that you input on this line. It also assumes that unless you specify the drive number, it is to search for the files on drive 1. So in other words, it follows the standard Atari convention of deferring to D1 when you just specify D colon. The files are separated by commas, and the input line is terminated by a carriage return. Now, say you had more than 2 files to link together, and they couldn't all fit on the line. Well, the linker requires that you then suffix the first line with what's called a /C toggle. And what the /C toggle does is it turns a flag on in the linker program that says, hey, I want to continue inputting some more files in there. And when you do that, then you'll get another prompt down here waiting for some more input of more files, what have you. And you can, I believe, use this prompt as many times as you wish, up to a maximum of 40 files to be linked. And that's just an arbitrary number that has been built into the system. Sometimes using the /C toggle can become a bit repetitious, and if you're doing repeated links and repeated editings of a program, you may have it down such that you know you're always going to be linking the same groups of files. The linker has a command in it that allows you to subvert all this extra typing and allows you to use a quasi-batch type command called the /F toggle. And basically what this toggle does is it allows you to call upon a source file that contains the various names of the programs you wish to link together. And then the linker parses through that command file and links those files that you've specified. Now there are some restrictions on using this feature, and that is one, the the file that contains the source input must have the extension .cmd to signify that it's a command file. Also, the source within that command file cannot contain any /f references. Okay, in other words, a batch file cannot call forth another batch file. However, it can freely use all the rest of the toggles here, such as the /c. So, for example, if the batch file that we've created or that we're going to create is going to contain, say, 30 names, we can use the /c toggle within that file to write out all the names of the files that are to be linked together. In fact, it is still required that if you go from one line to the next, that you don't overflow that line, and that if you need to include more input, you use the /c. Are there any questions on this feature at this time? Okay.
How do you give it a name, the file name?
Well, what you can do is go into Medit, create your file, and just give it any standard.
How do you do it in typing to the linker?
Okay. An example here would be, here's my prompt, and it might be D2 : batch .cmd, I believe.
You need the /f, don't you?
Right, yeah, /f. Okay. Any more questions on that? Okay. There's some variety of other linker switches, 3 of which are somewhat related together. Actually, wait, just these 2, these 3. There's the /m, /l, and /e switches. And basically what these do is generate to the screen during the linking process a memory map of the various variables, functions, and procedures that your program is calling, and showing where they're being linked to what, where they reside in memory, and where their location is. The /e toggle is you call it an extender or an optional switch that's appended with the /l or the /m switches. And basically what it allows you to do is to reference to those variables or functions or procedures that have $, question mark, or @ prefixes. And in most cases, you'll find these prefixes with system-associated libraries, such as in PASLib. There are a variety of procedures and functions that are prefaced with this. And so there's some use in that it allows you to see exactly what functions and procedures your program requires in conjunction with the PASLib library. Okay. Let's see. Also, somewhat associated with that is an undocumented toggle called the /t, or trace toggle. And what that does is, during link time, it will put forth to the screen an almost exact memory map of how the code is generated into memory, such that, say that you have your program orged at 2000, it will go from 2000 to the end of your program linking. It'll show all the various commands or Pascal commands that are generated with all the various variables and procedures and functions in an inline fashion. Any questions on the trace toggle or any of the others at this time? Okay. One other undocumented toggle is the /a, or abort toggle. basically the system has been configured such that, say, at the time that you're inputting into the link command line, you wish to stop and not use the linker. All you have to do is append a /A after whatever you've typed in already, and it will abort out of the linker process. In fact, there are various other illegal toggles you could say. You could say /Q, and the linker will not recognize what you've put in, and so will abort. Last time, I believe, I mentioned the search and extract switch. Basically, what this does is allow the linker to search a file library for only those particular modules that are necessary to resolve the link procedure. Basically, what the user can do is ahead of time create a file that is composed of 2 or more Pascal modules, that is, separately compiled modules, and compact them together into one file. And then during the link process, allow the linker to go through and abstract only those modules that contain functions or procedures that are necessary for the main program. Presently on the system disk, the only library that allows this is the paslib library, which contains the standard Pascal library procedures and functions.
The fplib also allows that file of floating point procedures.
Okay, I don't believe that's really well documented in there, but
No, it said, the documentation says it doesn't, but I was forced to do it because I ran out of memory.
okay.
It does.
Okay, so there's one more. The last 2 linker switches I'm going to talk about are the program and data code origin switches. And basically what these allow the user to do is to predefine where the actual runtime code will be origed at. That is, say you have a program that is going to be interspersed with some assembly language, or you wish to reserve a certain amount of memory for file manipulation, what have you. Or say you've run out of memory during the link process before. Well, what these switches allow you to do is to specify where the program code generation will be orged and where the data space will be reserved for your program. An example is if we take this, take an imaginary file called test. Okay. Okay, suppose we have this file called test, and during a normal link procedure, we get the message out of memory. One way we can get around that is to take the same string and enter the toggle /p : start address in hex. Say at this point we want to do 2000, and a data toggle at 8000 hex. Then what will occur is the linker will orge the generated runtime code at 2000 and resolve all data references to commence at 8000 on up in memory. What this does effectively is the generated runtime code will consist solely of this program section, and we'll assume that the data section has been zeroed out, or is whatever values are in there at runtime are inconsequential to the running of the code. This is also useful for saving space on a disk. Say if you've created a very large file that won't fit, you won't be saving the data space segment of the program on your file, so it gives you a more compact file. Are there any questions on these toggles? Okay. Okay, so there are some references in the Pascal documentation about linking the programs with assemblers. And generally, none of the Atari assemblers creates any compatible code with our linker. And the reason why that is because the linker expects a version of Microsoft relocatable linker format that isn't supported by any of them. We have in-house an assembler that works on the Altos computer that will allow you to do such linking, but currently we don't have the documentation for that. If any of you are interested in using it, you might see me afterwards and I can point you to it, so to speak, and give you what information I have. I just mentioned this in passing to clear up any confusion about any references the manual may make with regards to linking with a compatible assembler versus using AMAC or the assembler editor cart.
Dave, are you aware if the new specification for relocation will allow it to, will be compatible with Pascal or not?
Are you talking about the proposed linker loader?
Mm-hmm.
Okay, from what I understand, I've asked around about that, and they've, I believe, configured the linker such that it won't be compatible with Pascal. At least that was the last that I had heard. That's really too bad, because there is a need for such a beast, particularly when one considers that the native code compiler, which was to supplant the need for an assembler, a compatible assembler with the system. Since that compiler doesn't work, the user's sort of just left with creating straight P code programs rather than mixing P code and assembly or P code and native code compiled program segments. Perhaps in the future we may come up with a linker that works, or may come up with an alternative version of Pascal that will use those linkers. I think that's still yet to be determined, and it's probably unlikely.
So that's what the system group had in mind.
Pardon?
They're going to make their own linker which will be compatible among the new products. And if somebody wants, they have to go back to this thing and change it to conform to the new state of their...
Right. So perhaps in the future, if we ever decide to revisit the Pascal source, we could change it such that it could use that linker. However, right now it seems a little bit unlikely. Okay. As I mentioned last time, on the system disks, there are a variety of libraries that come to support the various Pascal and non-standard Pascal functions. These libraries are the PASLib, FPlib, and GRSND, or graphic sound libraries. And they support those functions and procedures that are normal to Pascal, and those floating point, color, graphics, and sound procedures that are particular and peculiar to the Atari. For the most part, they're well documented in the Pascal documentation, and I really won't be touching upon them all specifically. However, what I hope to do in the next couple of minutes is illustrate to you some of those functions, particularly the graphics and sound functions and procedures. At this moment, I'm going to load in a program that MT Microsystems composed for us to demonstrate those graphics and sound procedures.
You always need 2 drives to run something.
No, you could get by with one drive.
Oh.
I mean, that's to run something, not to compile or link. Okay, this program is called Test Graphic Sound. It was composed by MT Microsystems for Atari just to demonstrate the various graphics and sound features that they had implemented in Pascal. In the handout that I gave last week, I included a listing of this, and in fact a listing of several of the other programs that we're going to be demoing today. Basically what this allows you to do is to enter in one-word commands and then follow it with a carriage return, and it will show the particular function you've asked for. In this case, we could ask for a sound command and choose the voice that we wish, and the pitch and the distortion and volume. Okay. There's a general, let me turn this down for a moment. This command basically is patterned after the one that one sees in Atari Basic. That is, the structure of the command is sound with the voice, what is it, pitch, distortion and volume specified as in Atari Basic. Most of these graphics and sound commands are similar in structure to Atari Basic. There's another command that turns all sounds off. This is called sound off. Pretty straightforward and simple. Let's see. We can also call forth the graphics mode. And specify whether we want a full or a split screen, and to clear or not to clear the screen. Now there's a information function in Pascal called grresult, and generally whenever one calls forth for a particular graphics or sound command, this variable has stuffed into it the result of that function call, and in this case it's a 0, signifying that we were able to create a graphics 3 screen. Sometimes you see a variety of other numbers. Sometimes these numbers, whenever they're not 0, they indicate an error. Sometimes they just tell the user of some particular system information. The actual numbers themselves are talked about within the documentation, and I won't bother going over them today. What I can show you now is examples of the plot, draw to, and fill command. Let's see. Also the color command here. this out again. Okay. As you can tell, the command is pretty much identical to Atari Basic. Are there any questions about this program at this time, or any of the particular functions? There are a variety of others I can demonstrate if you like. Basically, the internal workings of these functions are such that they are similar to the XIO commands in Atari Basic. In fact, there is an XIO command, but it's not documented really within the released documentation. It's just a part of the system listings that we have here. In fact, it's called XIO, and it's an assembly language routine within the PASLib library. I have some documentation of it, and I can make it available to people on request. To be frank with you, there's quite a bit of peeking and poking one must do in order to effectively use the XIO command. It's buried a couple of layers deep within the library routines, and so isn't really that accessible, although you can use it. I think at this time I'd like to ask Bob Fruth to come up and demonstrate a player missile program that he composed. In fact, it's part of the documentation that's released with the Pascal program. Let's see. I better leave that in there. I got the system disk in there for me now. Hey, you want this?
Okay, I'll boot this thing up first and then explain the handout. Actually, maybe I should explain the handout first. What it is, it's a player missile graphics demonstration program, and it was based on this rather old program written by Chris Crawford in BASIC, and that's what the first page is. And his program is rather slow and doesn't cover any error checking at all, so if you go off the screen, funny things happen. Then the second page is called Module Peek Poke, and this basically gives a couple of Pascal routines which do the same thing as the peek and poke commands in BASIC. And as you can tell, I put in what was then the Atari standard documentation for procedures, so that the comments are longer than the programs themselves. And the third page is the sound, gives the sound for the engine of the player, so when the player moves, it makes some noise. And the only reason I put this in its own module is because I compiled it with a native code compiler, and it was a one-line module essentially, just with that sound reference, and that was about the longest thing I was able to get to compile with the native code compiler. Let's see, and then the following module is PM Missile, which just is called when the trigger is pressed on the joystick, and basically it clears out the missile, sets it up, fires it, moves it, and has a little noise associated with it. And then the last three pages give the main program itself, which basically all that happens is that there's a procedure set player on the second page, which sets the player up in player memory. And then there are four procedures called move right, move left, move up, and move down. And they are called according to the joystick inputs. And then the main program is fairly self-explanatory. I will comment that this is faster than Chris's program, even with all the additional error checking and sounds and the missile movement. And it is not as fast as 6502, of course, but that's your trade-off. Okay, there's your player in a graphics 0 screen, and as you can see, it moves, and missiles are fired. And I have it set up so that there's simultaneous movement of the player and missile. Unfortunately, as you can see, it slows both the player and missile down. If I fire from up here, if I stop moving the player, the missile suddenly takes off with a burst of speed. But my primary reason for writing the program in the first place was to demonstrate that, yes, you could do these fun things in Atari Pascal, and that it wasn't difficult, and that anybody who could write it in BASIC generally probably could write it in Pascal with the same amount of ease. I will demonstrate that it does also have error checking so that it doesn't go off the screen. Chris's program, if you take it off horizontally, it returns one of the error 130 something, and if you take it off vertically, it screws up player missile memory. So I fixed that in this version. That's basically it.
Does Chris's program fire a missile also?
No, it does not. It just puts the player on the screen and moves it around.
Doesn't make any noise either.
Doesn't make any noise either.
What does your missile do when you fire and you're moving horizontally? Does it go follow the...
It just goes straight up.
Bob, when you designed this program, now that you've done it, if you started over again, would you have done it a different way?
It's hard to say. I did follow Chris's program pretty much to the letter because I was not too familiar with the player missile graphics at the time that I designed it, so I followed his because I knew his worked except for the error checking that
So
needed to
you're
be
kind
put
of
in.
emulating his...
Basically, yeah. And I would expect there'd be a better way to write it in Pascal. I have not sat down and tried to do it. Were there any more questions?
Okay, thanks, Bob. Alrighty, let's see. We have one more. Well, I have one more program to show you relating to color graphics in an indirect fashion, and also to assembly language. What I'm going to show you is a program that is an example from Day Ray Atari that illustrates using a display list interrupt. And what I've done is I've written a small Pascal program that effectively pokes in a machine language routine that creates a display list interrupt on the screen. Let's see, let me load it in here and we can continue. Okay, not on there. Okay, basically what this program does is creates a display list interrupt midway down the screen and changes the color of the screen from blue to pink. As I mentioned before, there is no assembler no Atari assembler that is currently compatible with a Pascal language system. However, you can use assembly language that's been pre-assembled and inserted into your Pascal program using what's called an inline function. I think we have a problem here. We're having a few technical difficulties here, if you'll bear with me for a moment. Okay, there we go. As I was mentioning, you can't really link an assembly language routine with Pascal, but through the use of what's called the inline function, which is a Pascal extension, and it's a non-ISO standard function supplied by MT for us. With it, you can insert a variety of bytes or word variables or constants or addresses or what have you. It takes the format in Pascal source of inline number slash number slash number, so on and so forth, until you're done, close parenthesis. And the numbers that you insert here can be decimal or binary or any other valid number that with a valid prefix. So it could be hexadecimal, octal, what have you. Basically what I did for this was I assembled my DLI routine and then took the assembled code and put the pertinent bytes within it and ordered the program to be relocatable. And what that program does is pokes in the address of the inline routine into the display list interrupt vector. Now, I guess I should kind of specify that Pascal itself is not interpreting this inline function. All I've done really within the Pascal program is set aside an area of memory to which resides this program. Okay, I don't make any procedural calls. I don't make any function calls of any nature. What happens is when the program's loaded in, this program and its address are loaded into the display list vector. Now you can do this with vblank, immediate, and deferred. Basically, you could do this with any vector on page 2, given the constraint that you realize that Pascal itself is not interpreting this, and that where you place your routine, it must not conflict with any of the Pascal interpreter tables or the interpreter itself, or with your program or any of the data area that it chooses to use. I believe I've included a listing of it. If I haven't, it's available if you like later on. Are there any? Go ahead.
So that means that you can't call it directly, but you get to it through vblank or the display list, whatever.
Right. For a while I've been working on truly interfacing the two together, and to be real frank, I'm a little stymied here as to really allowing Pascal to recognize assembly language routines within the program. If I ever get it done, I'll let the world know.
So the inline, you compile out as a separate module and has its own origin.
Well, you can. Well, what you do is you assemble your machine code routine separately, and then you take the byte representations and you plug that into your source here.
But then that source is in its own separate module or procedure.
Right. The only thing that I've...
I'm just trying to get a
Sure.
feel for how you set the origin of it.
Okay. Well, the only thing that I've done in order to set the origin of this is that in Pascal, what I do is I take the address. There's a function called the ADDR, or address function, and it can be used to return a value of a particular procedure or function or variable. Anyways, I call this, say, procedure DLI, say. And then what I do, well, I have a begin and end statement, of course. Okay, then in my main program, what I do is I get the address of this procedure. I say ADDR of DLI, and I store that address into the display list interrupt vector. And that's what you do with interfacing assembly language to any of these vectors. But as far as actually calling DLI in your mainline program, you're never actually doing it. The only Pascal interface between the two is passing the address of this sequence to the particular vector that you wish.
So then the assembly language program you write has to be
relocatable. Yes.
Because you could only control it by setting the origin with a linker switch, and then
Right.
You really have any control over it? Is that?
Well, there are a couple of things you can do. I mean, your program can access system variables, such as you could perhaps come up with an I/O routine that uses the IOCBs, but you have to make sure that your Pascal program isn't going to be using those exact same IOCBs. So generally, the safest practice is use IOCB 7 and work your way backwards, because Pascal sort of works its way from 0 on down. So you could use absolute locations like the system equate ICOM by X, whatever, the command, IOCB command. You can reference that as an absolute within your relocatable code. However, if you're trying to store some number as a tag on the end of your code, it has to be relative. Okay, it cannot store into an absolute area high up into the program. It can only store or load absolutes from within the system equates. Any questions on that?
I don't understand why it has to be relocatable.
Well, in case you do any jumps or jump indirects
To where?
to wherever within the routine, to say another assembly language routine, you don't know where it's going to necessarily reside. Say I have two assembly language routines, one that calls forth another one as a JSR. Okay. I don't really know until compile time what the address of this inline function, of the second inline function, is going to be. And as yet, I don't really have any direct way of passing
I'm not
that
talking about
address.
passing, I'm talking about user explicitly set it by using the switches.
Okay, you can through the switches, I suppose.
That's right.
But that's if you know where your program area and your data area for the Pascal portion end exactly. So you'll have to go through a few repetitive link procedures.
You have to use a manual link.
Yeah, that's where this trace comes in handy. Okay.
But the methodology is essentially like the USR function, or basic. Basically, you got data statements there.
Right, but in Atari Basic, you pass parameters. Okay.
Stack, yeah.
And supposedly you do the same after a fashion in Pascal. How that exactly works isn't clear to me, so I can't really relate that to you today. I do know that the method that I've shown you will work, so that's one avenue. Are there any other questions on this? Okay. Throughout the lectures I've mentioned modular compilation. Rather than go into it again, I might ask if there's anyone who doesn't understand what I've been talking about all along, would like some amplification. Okay. I assume then you all understand what I mean by modular compilation then. Okay. Given that, I'm going to skip on now to program chaining. and what that is in Pascal. Are we running out of time? Okay. Oh, my handouts are here. Okay, I guess we'll continue this next week. I don't anticipate we're going to be using a full hour, but in case we do, the subjects that I'm going to talk about next time are program chaining,